Welcome all of you to the 66th lecture of Digital Electronics. In lecture number 62 to 65, we were dealing with multiplexers. What is basically a multiplexer? Multiplexer is basically a data structure. And how to design a 4x1 multiplexer, 2x1 multiplexer, 8x1 multiplexer, 16x1 multiplexer, and realization of 16x1 multiplexer using 8x1 multiplexer is being handled in lecture number 65. Now, moving further, in this lecture, what we are going to deal is, suppose if we are having a higher order multiplexer, say 16x1 multiplexer, how to realize that 16x1 multiplexer using a lower order multiplexer. That means, suppose if I am having a 16x1 multiplexer, how to realize it using a lower order. For example, it is 4x1 multiplexer. Okay. So if you are normally looking to the ratio of division, you can directly say that we require 4 marks. But whether that is right or wrong, that is the next question. Okay. Right or wrong? Okay. There is a doubt in that. See, 16 to 4. That means if you are looking directly, what you can say is that you require 4x1 marks to realize 16x1 marks. Whether that ideology is right or wrong. Okay. So that is what we are going to prove in this lecture. Okay. Now, this ideology can be right or wrong. Maybe I will prove it as right, or maybe I will prove it as wrong. Okay. So that is a key point in this lecture which you need to take care of. Now, moving further into the lecture, let me go into the truth table of 16x1 marks. Okay. So we are having now to get this 16x1 marks, what you are having? You are having 4 selector switches. Okay. You are having 4 selectors. Okay. So selectors are S3, S2, S1, and S0. Or instead of this S1, S2, S3, and S0, let me make it as a different thing. And I'll make it into A, B, C, and D. Okay. And this is the output. Output is this out. Okay. So I am having 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. Yeah. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 0, 0, 1, 1. 0, 0, 1, 1. 0, 0, 1, 1. 0, 0, 1, 1. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1. So you have D0, D1, that is output. D0, D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, D11, D12, D13, D14, and last one is what we have is D15. Now if you are looking here, now I need to realize this. My aim is to realize a 16x1 marks using a 4x1 marks. So how to realize this using a 4x1 marks? That is the question. Okay. So to realize it using 4 by 1 maths. Okay. How to do with that? So take C and D as or you can divide it into 4 sets. Sorry, you can divide it into 4 sets like this. Okay. Take the first 4 elements. Okay, D0, D1, D2, D3. That is the first set. The second set what you have is D4, D5, D6 and D7. Second set is our. Third set is D8, D9, D10, D11. Third set. And last set is D12, D13, D14 and D15. Now if you are looking into, if you are deeply looking into this, what you can see a peculiarity. What is the peculiarity there? See, this C and CD term here. Okay. CD. That is getting repeated. That same CD is getting repeated here. Okay. The same values of CD is getting repeated here. Again, the same thing. That means it is in the order 0, 0, 0, 1, 1, 0, 1, 1. Okay. So you can see that the same order is being repeated in CD. Now, what happens to AB? A can be, that is if you are taking the division of if you are taking the division of 4 for each, you cannot see that directly. Okay. Now, how to realize this? Okay, that is the next question. Now coming into that. Okay. Now. Okay. Okay. Now if you need to realize the first part, okay, suppose I need to realize the first part only, I can choose this CD as my selector, right? Okay, that means here what I can do is, and in the second also I can use CD as my selector, CD and AB as a selector. Or if I am choosing CD as a selector here, I can select D0, D1, D2, D3. Similarly, taking the same CD as selector, I can select D4, D5, D6 and D7. So same CD as selector, I can take D8, D9, D10, D11. Okay. Now let me try with that first. Okay. So here what happens is that, suppose I am having a 4 by 1 maths. I am having a 4 by 1 maths. 4 by 1 maths means what? I should have only 2 selectors, right? That 2 selectors I am choosing as C and D. So selectors I am choosing as C and D. Okay. And what are the data inputs? Data inputs are D0, D1, D2 and D3. So I am having D0, D1, D2 and D3. Okay. So the corresponding output is Z1. Now another 4 by 1 maths with the same combination of CD. I can have D4, D5, D6 and D7. Right. So I am having the same combination of C and D. C is there. Similarly, D is there. Here what I can have? What are data? What I can have is D4, D5, D6 and D7. So this is D4, D5, D6 and D7. Okay. Let it be Z2. Okay. Again, with the same combination of CD, I can have D8, D9, D10, D11. I can select any one of these, right? So I am having C here. Okay, so D I am taking from here. C I am taking like this. Okay. So here I have D8, D8, D9, D10 and D11. I can select any one of these 4. The output is Z3. Again, with the same combination of CD, I can select D12, D13, D14 and D15. Right? So another 4 by 1 maths. So this is 4 by 1 maths. This is also 4 by 1 maths. And using another 4 by 1 maths, I can select D12, D13, D14 and D15. Right? D12, D13, D14 and D15. That means 4 by 1 much means it has two selectors. Which are the selectors? The selectors I am using it as C and D. So C is here. I am taking the C and D is there, and this is D. Okay, you can show that selected there also, no problem. So what will I get is Z4. Okay, that means here when C is equal to 0, when C is equal to 0 and D is equal to 0, okay, the first 4 by 1 much gives the output of D0, second one gives D4, third one gives D8, and the fourth one gives D12. Again, when C and D values are 0 and 1, the first 4 by 1 much gives D1, the second one gives D5, the third one gives D9, and the fourth one gives D13. Similarly, if C is 1 and D is 0, the first 4 by 1 much gives D2, second one gives D6, then gives D10, and the last one gives D14. Now, if C and D is equal to 1, the order is D3, D7, D11, D15 respectively. Okay, that is what is depicted from this figure. Now, you need one more 4 by 1 much, because you need to select from which much, because these comes out from much number 1. So this is much 1, much 2, much 3, much 4. These comes from much 1. These 4 elements comes from much 2. These 4 elements comes from much 3. These 4 elements comes from much number 4. So you need to know from which much which output is coming, right? So for this much at a time you have one output. For this much another output at a time. Here for this much another output. For this much another output. Okay, that means at a time each much has only one output. So what happens? You need to search from these 4. So how many total outputs will be there? Total there will be 4 outputs from these 4 muches. So and you need to select one from that. So what is the idea behind that? Select or make another 4 by 1 much. Make another 4 by 1 much. Make another 4 by 1 much. And for that 4 by 1 much, what should be the output? What should be the data selector? So here I have formed Z1, Z2, Z3 and Z4. So for that you can have Z1 as one input, Z2 as another input, Z3 as another input, and Z4 as another input. Okay, so you are having Z1, Z2, Z3 and Z4 of this much 1, much 2, much 3 and much 4. There, what are the selectors? The selectors becomes what? A and B. There the selectors are A and B, like this. Okay. So if A is equal to 0, B is equal to 0, what happens? The much number output of much number 1 will be selected. What is it? That is Z1. Again, if A is equal to 0 and B is equal to 1, what will be selected? Much number 2 will be selected. Again, if you are taking this combination, when A is equal to 1 and B is equal to 0, which will be selected? The output of much 3 will be selected. Again, when A is equal to 1 and B is equal to 1, which will be selected? Much 4 will be selected. That is Z1. That means Z1 corresponds to C is equal to 0. That is this combination of CD plus A is equal to 0 and B is equal to 0. Okay. And here we can have selectors as A and B. That are the selectors which is for the 5th month. And the effective output is Z. So you can directly connect Z1 to here. Okay. So you can directly connect Z1 like this. Similarly, Z2 should be connected here. Z3 you can connect like this. And Z4 it should be connected here. Okay. So what you can see, the last much will select from which much. That means from much 1, much 2, much 3 or much 4, which output is coming, and from that it will select which much, and that each much selected which data is there. Okay. So that is how we are realizing a 16 by 1 much using 4 by 1 much. Okay. That means here the key concept is when C is equal to 0, D is equal to 0, which are the data that can be selected? D0, D4, D8, D12. These are the data which can be selected. Okay. For example, when C is equal to 0, D is equal to 0. What are the data which can be selected? The data which can be selected are D0, D4, D8 and D12. These are the only data that can be selected. Again, in that case, when A is equal to 0, B is equal to 0, which will be selected? When A is equal to 0 and B is equal to 0, which data will be selected? D0 will be selected. Okay. Now, when A is equal to 0 and B is equal to 1, which will be selected? When A is equal to 0, B is equal to 1, which one will be selected? D4 will be selected. Again, when A is equal to 1, when A is equal to 1 and B is equal to 0, in that case, B is equal to 0, which will be selected? D8 will be selected. Again, when A is equal to 1 and B is equal to 1, which will be selected? D12 will be selected. Okay. Provided this is a condition. C is equal to 0 and D is equal to 0. Now, again, next condition is when C is equal to 0 and D is equal to 1, which data that can be selected? D1, D5, D9 and D13. So, in that case, when A is equal to 0, B is equal to 0, which data will be output? D1. When A is equal to 0 and B is equal to 1, which will be output? D5 will be output. Again, when A is equal to 1 and B is equal to 0, what will be output? D9. And when A is equal to 1 and B is equal to 1, which will be output? D13 will be the output. So, I think you have got the concept of realizing a 16 by 1 maths using 4 by 1 maths. Okay. So, if you are drawing a truth table for that, right, that means, yeah, like I am making C is equal to 0, D is equal to 0. That is the first condition, what I am making. Okay. When C is equal to 0, D is equal to 0, you can have values of A and B. A, B. Then you can select the which one is the output. So A can be 0, B can be 0. 0, 1, 1, 0, 1, 1. So in this case, what is there? In this case, what is there? When A is equal to 0 and C is equal to 0 and D is equal to 0, you have D0, D4, D8 and D, when A is equal to 1, B is equal to 1, this D12. Yeah. So it is D0, D4, D8 and D12. D0, D4, D8 and D12. Okay. Again, when C is equal to 0 and D is equal to 1, that is the next case. So, what will be the value of A and B? And what is the output? Is that? Okay. So, 0, 0, 0, 1, 1, 0, 1, 1. When A is equal to 0 and B is equal to 0 and C is equal to 0 and D is equal to 1, that means you will have D1, D5, D9 and D13. D1, D5, D9 and D13 will be selected. Again, when C is equal to 1 and D is equal to 0, what will be there? If you are having A and B, what is the output? Is that? Again having 0, 0, 0, 1, 1, 0, 1, 1. So we are having D1, D2, D6, D10 and D14. Again, when C is equal to 1 and D is equal to 1, that is the last case. When C is equal to 1 and D is equal to 1, depending on the values of A and B, you can select, right? So A, B is there, that is selected, and what is the output? Is that? That is the question. So we are having 0, 0, 0, 1, 1, 0, 1, 1. So what we have? We are having D0, D1, D2, D3, you can select D3, D7, D11, D15, D3, D7, D11 and D15. Okay. So that is a simplified truth table of this 16 by 1 maths using 4 by 1 maths. That means here the key idea is, so from which point where I have started, whether 16 by 1 maths can be realized using 4 by 1 maths, that is possible. But 4 is not the right number. We need 5 4 by 1 maths to realize 16 by 1 maths. Okay. So that is a key point which I need to make in this lecture. Okay. So in this lecture, what we have done is we have realized a 16 by 1 maths using 4 by 1 maths, and how that is done. That is based on the selectors. The selectors are A, B, C, and D. So initially I have pointed out C and D first, and based on C and D I can select D0, D1, D2, and D3. And for the maths 1, the output is Z1. For the maths 2, Z2. Maths 3, Z4. And maths 4, I am taking it as Z4. Now come to A and B values. Now see, I need to select which maths and which data. That is right. So I have chosen A and B separately. And here when A is equal to 0, B is equal to 0. Again depending on C and D. And if C is equal to 0 and D is equal to 0, you will get the data as D0. And that D0 will come as output Z. Okay, so I think you have got the concept of realizing a 16 by 1 maths using 4 by 1 maths. Okay, so I have explained one example. So in a similar way, you can realize a 32 by 1 maths using 15 by 1 maths, or 32 by 1 maths using 8 by 1 maths, or 32 by 1 maths using this 4 by 1 maths, or even 2 by 1 maths. Okay. So I have given one example. So thank you, and thank you for listening to this lecture. And in the next lecture, we will be starting with some applications of multiplexers, and after that we will deal with demultiplexers. Thank you.